What we are going to do here, we have a new feature called ResFrac command line interface, that is a CLI. I will talk through a little bit about what the CLI is and what is the intended audience for this program and how to use this with a small demo, and then take questions. The CLI is a command line program tool mainly intended for power users who are comfortable writing scripts and are using the command line interface instead of a graphical interface, which is our ResFrac Pro software. The CLI is in a version 1. At this time, you will be able to perform some actions using CLI, like validating input setting files in case if you have modified any of the ResFrac simulation files manually. You could use the CLI to validate them. You could also make changes to the in one or two more parameters in the input and setting files using CLI instead of editing them in a text editor. You could submit them to ResFrac Cloud Services and check the status, what's happening, and also download results. There are a few more other logistical commands available within the CLI. There is a detailed document available. The CLI program can also be used in a batch programs like Windows batch script or a Linux shell or even Python or any other programming language that you are comfortable with. For today's demo, I will be showing you using a Windows batch script. As I go through the presentation, please feel free to ask any questions or anything. Giving a little more detail, I verbose notes about what the scenario that we are going to talk about is. Some advanced users, they would like to take a base simulation, make some changes, like say 1 or 2 or 3 parameters to them, copy them and run them. And again, make some changes, run them. So they repeat these steps like 5, 7, 8 times so that they can observe the simulation behavior by varying 1 or 2 parameters. At this time, the only way to do this is using ResFrac Pro software, and it takes about 4-5 minutes per simulation. You open a simulation, make a copy of it, make some changes, run it, and then go to the next one. So these steps, they take some time, and some of the advanced users have reached out to us looking for more programmatic ways. So that's how we built this CLI software. This is available in Windows, Linux, and Mac as well. So you could use any of your operating systems to run the CLI. Before we go into the demo, what I wanted to set expectations is this demo assumes certain prerequisites from the users that they are familiar with the ResFrac software and also setting up simulation. Even though I can quickly give a very brief look how that looks like, but as I go along, I'm assuming the audience of this having this understanding of how the ResFrac simulation is set up, and mainly how the input and setting files look like. I will show them very quickly. So in this demo, what we are today I have is I have a small Windows batch script written using ResFrac CLI and some plain DOS commands. So what we are going to do is we are going to take one base simulation, which I'll show in a minute, and identify one parameter that we would like to. So in this case, I've written a script to vary global permeability multiplier parameter, and then submit the simulation. So before getting in, quickly showing up how the CLI is set up on my system. So for the purpose of this demo, the CLI is set up on my system, and most probably any users who will have access to the CLI will have a similar setup. So this is the CLI folder. There are a bunch of files. The main program is this ResFrac CLI win.exe. It could be this one. And then there is a simulation folder. These are the two places that you need to be aware. The simulation folder is a default folder that ResFrac provides with at least one or two demo files so that you have access to them. There are similar files available in ResFrac Pro software as well. So the input, each of the ResFrac simulations are saved in these two files. One is called input and one is settings. Just taking a quick look how the file looks like. It has its own format and you need to be aware about, and we may not go through the full details of how this file looks like and the file's architecture in this demo. That can be a separate topic. Assuming like the users are aware about how this file looks like and they are able to navigate through and identify what parameters and where the values are and how to do. Settings file looks very similar, slightly larger because it has a lot more values in it. What we are going to do in this demo is we want to take a look at one of the base simulations and identify a base parameter. The CLI requires you to know the internal name of any parameter that you would like to vary. So one way to find that is using the ResFrac software. So if we go into the software and edit the simulation, since we are interested in finding out the private name of global permeability multiplier, which is on a static model panel, and that when we go to this particular parameter, we have a small question mark that gives a tooltip, which includes a full path. So this full path parameter will show you what the private name is. This is available in upcoming versions of ResFrac software. This is a new feature. And at that time, on any of the help files, when you go, you will be able to pick this up. So this is the one piece of information you will need for our demo purpose. So which we will take this. Beyond that, if you would like to make any changes to this base simulation in this, you could make them and close it off. So that's one expectation. And before we go ahead and run the demo, so the second piece is you need 4 pieces of information that we are going to leverage in this demo. One is where your base simulation is located, the folder where it is located, which is our case here, and the name of the simulation. It is very important to have this name correctly, because then our remaining program will use it programmatically identify various files and perform actions. So it's not case sensitive, but spaces and other special characters need to be taken care of. And once we have this simulation information, we are also going to, this is where we are going to configure the element that we want to vary or modify. So the private path that we modified, we will paste it here. And the value of the global permeability map, what is the new value that we want to provide, we can put. So we have seen in the UI that current value is set to 1. So let us say we want to change the value to 1.1. And once we set these 4 parameters, the script is written. I will walk through in a bit if required. But for now, let us assume that we have this script ready. One of the things I wanted to call out is the script is not the only way. We can directly use ResFrac CLI to perform a lot of the commands, which I will talk about in a minute. So I want to first run the command so that we give few minutes for it to reach cloud services and get working on it so that we can actually see it in full action. So I'm going to now run. One other thing I did in this script file just for the purpose of this demo is I have placed some pause commands so that we can see as script progress how it is doing. So this is my demo file. So at this time, if you see, it has identified that the new demo name that we want to use is demo1_3. So just randomly suffixing a number. And it made a copy of our base simulation, 2 files copied, if you see this showing. And it's also identified that this is a parameter that we are going to vary with this new value. And once I press this, it's going to so what it did in the next step is it went ahead and modified the parameter. At this time, if we come back into this folder and see these new files that got created, and if we go into these files, you will be able to see that the value is now 1.1. Let me quickly show you that. Yep. You see that the value is 1.1. So at this time, it has created new files and modified the value. And the next step would be to submit it to the ResFrac cloud services. It takes like a few seconds. Should do it in about 30 to 40 seconds. Yep. So as you can see, the job is submitted successfully, and it is providing us the information like the ID that it auto-generated and where the simulations are available. At this time, if you go back and look into this folder, there is a new folder that got created with the new simulation name that we provided and new simulation files. At this time, the current status is blank because it just submitted to the cloud. And after a few minutes, if we come back, we will be able to see that the status getting updated, and we will be able to download the results files. So that's a quick demo of how to submit the simulation, make changes and submit the simulation very quickly. Without these pauses, this whole thing would have been completed in under a minute. Yeah, that's a quick demo. And we have some help files available, how to get started, very detailed documentation available on cloud. So I won't go through and drain them, but I just want to let you know that there is a file which will help users. Any users interested in using this software, they need to reach out to us so that we can provide them a software configured for their specific use. And in case interested, we can do a quick look at how the batch file is written. So it's a basic Windows batch file, like as I shown. The core programming is around calling the ResFrac CLI here, passing parameters. Everything else, you don't have to use, like I said, Windows batch. You could use Linux shell or Python or any other programming language that you are comfortable. And to quickly answer the one question that I saw is around firewalls. Yes, I'm working on it, and I think we have a solution, but we haven't tested it very well. So in the next few days, the ResFrac CLI will support handling firewalls and proxy services, the challenges that we experienced. So yeah, we will send out an email in the next, as soon as we are done. So that's one thing in progress. Apart from that, ResFrac CLI uses SSL certificate for authenticating. So a lot of security is already being built in to meet enterprise security requirements. That's it. So any questions?
There's a second question that just came. Is it possible to submit more than one value for the parameters? For example, 5 values for the global permeability multiplier.
Yes. So at this time, so let me quickly show you a couple of small things here. So the parameters that we can vary is we have 3 parameters. So this is how, so there is an online help continuously available. There are 3 parameters of interest here. What we have seen in this demo is using these 2 parameters. One is an element name and a value. We will also support an array of elements using this specific format, wherein you can prepare an array of element name, key value pairs and submit them. So yes, it will support submit, changing multiple parameters in that one.
And do you mind if I make a remark here as well, Soma?
Yes, Charles, please go ahead. Yeah, and just wanted to point out that Charles has been very helpful in preparing and setting up this CLI. So he's kind of a co-developer on this program, so he has full understanding. Yeah, please go ahead, Charles.
Yep. Yeah, thanks. Yeah, so to answer the question of, so what Soma showed just now is you can vary 1 parameter at a time, or you could vary 2 or any number of parameters in one simulation. And the question here is also, I think, asking about if you want to do a parametric study. So let's say you wanted to have global permeability multiplier go from 0.1 to 1 to 10 to 100, right? You have 4 different choices or 5 different choices. So you could run the CLI inside of a script, right, and generate 5 simulations and do a parametric study that way. And you just run the save command 5 times, right, with different values for the set value. So you could do that. You could also do a combination. You could have 2 variables. You vary those along 5 steps along 2 variables. You'd have 25 simulations. That's the beauty of having a CLI like this, is that you can write your own script. And I think some actually you have an example of doing this inside a loop, right? So this is if you can write a program to generate it. Yep.
Yeah. This is one is where you can actually have within one file you can have multiple sets of commands, wherein you can vary different parameters, different values. So that's one way to do. The second way is, let me get the for loop. You could write a for loop, wherein within the for loop, then you could actually programmatically calculate the value and vary it. So you can put a for loop and submit, same program. You could do that. Yep.
Okay. Another question coming in. So if we run the CLI, we may do a whole bunch of cases. So then the question is on post-processing, is there any way to automatically generate images or maybe generate a whole bunch together, which is a good preview maybe for a new release coming out?
Yes, absolutely. So one thing what we can do here is, so in our, I think the next release, which should be very shortly, in ResFrac UI, there is a feature that will let you, so what you can do is whatever number of simulations you ran using CLI, you could import them very easily just by pointing them to the folder in the ResFrac UI. And once you are there, you could batch generate various plots. So maybe Charles or Garrett or Mark could talk more about that feature.
Yeah, so I think we'll probably demo that feature in 2 weeks during the next session. Mm-hmm. But the next release of the UI to go out is going to have a batch generate plot function. And it already has a batch import function. So you can import a folder of folders if you want to import multiple simulations at once, which will then populate them in the UI. And then the coming release will have a feature where you can save a visualization layout. And then from the job manager, you could select 15 simulations and make that same image with all 15 simulations. Alternatively, there's also going to be a function where you can select those 15 simulations and open them into a line plot where you can then, instead of doing the load external data for each of the individual 15 simulations, it would pre-populate all 15. So very excited for that to come out.
So the other question is, how do we see the status? So like I said, we submitted a simulation a little while back. There are additional commands available within CLI to check the status of the file as well as download the results. So if you see what this is showing the simulations that we have submitted using. So this is the simulation that we just submitted, and now it is running on the compute pool. So status got updated, and it was submitted at 1421, and it started running. So it's not finished, so end time is null. So this way, just by running a command called ResFrac CLI list, you could get. There is also an additional another command in case if you have too many simulations and don't want to go through a large list. You could also use simjob and provide just the name. And what that will show you is that one particular simulations. So this is useful in programmatic looking up, because we know the new simulation name that we generated and submitted, we can check the status. So in this, this is a key value pair, a JSON. So if you capture this, you can also look up. That's the one. Second is there are various options available. In ResFrac Pro UI, if you submit a simulation, all the results are automatically downloaded. The control is less granular there, but program does in the background, so user is not impacted. Here you have various options to download. So let me show you the results. Now that the simulation is running already on cloud. So there are various commands available, and you have options to download just any one or more restart files, or simjob track file, or comments file, or all results. So this provides you a lot more flexibility in case if you want to just look up the comments file and see what happened, or a track file, and then decide to whether download results or not. So this gives you a full scope to download the results. The ResFrac results will allow you to download all the results at one time, or one simulation at a time as well. Again. So. If we're going to, so it started downloading. It takes a couple minutes to finish up, so you can see that all the results are being downloaded. Hope that answers the question.
Another incoming question for you here, Soma. What, if any, restrictions exist on the parameters that can be changed? So we're modifying text files. Are there any of those keywords that we cannot change?
At this time, I don't think there are any restrictions, but especially if you are modifying a parameter that takes a very large text, you need to be careful about passing it from command line. If you're doing it programmatically, yes, you can do it. We don't have any restrictions. So if it is numeric number values, it's very easy to send, but if you are sending any kind of large text values, just need to be careful with mainly escape characters and that kind of thing. We are building in features to handle such scenarios, but yeah, other than that, there is no limitation. Any parameter that you can change using UI can be changed using CLI.
So an example there may be like the static model is often a huge table that's maybe 30 columns wide and 100 columns or 100 rows long. And each of those values needs to be tabbed eliminated. And so I think that would be the, to make sure that you do so correctly if you're trying to enter from a command line.
Yes, you're right. One is getting, those, for tables mainly getting a private path is going to be a little tricky, but yeah, once you get the private paths of all the columns and you're able to build the array of key value pair for changes, technically the CLI won't stop you anything because it uses a similar program that is used by a ResFrac Pro software to make changes in the background. So it's a code share, so performs very similar action.
So just one quick comment about that. I agree with everything both of you that you said. With tables and things that are inside those unfolding accordion items like curve sets, I think a bit of a challenge that you might face is that each individual cell in a table has a name. So if you wanted to change like an individual cell, you'd have to be careful about constructing the name of that value for that cell. But there's no technical limitation. It's just a matter of knowing the name and getting the naming pattern down right. Because you could change the third row with a third column, which is you have to count cells and all that. Right?
Well, if anyone has questions on that, they can email yourself and Soma, right, to get help
That's
on
right.
the correct path.
Yeah.
And I guess another limitation is that in the UI you can add rows and remove rows and things like that. In the CLI, we currently only have the support for changing a value. You can't like delete a curve set, for example.
Yeah. One thing we are also looking forward for feedback is, any kind of different scenarios that you think that might be useful for adding to the CLI. Please do let us know. We will look at them and see if we can prioritize based on amount of work and number of people looking for that. Or at least we will be able to provide you guidance on how you could use CLI to meet your needs. Please feel free to write a mail to Charles or me or Mark. These are the same files. So just their location, yeah, need to track, no changes, exactly same files. And they are interoperable. So a CLI file, input setting files modified by CLI or UI are very much same.
Great.
And actually just adding to that, is not just the input and settings files, it's the actual, everything in the folder is identical. So you can even just take a folder that you downloaded results to in the CLI and copy paste it into the simulation folder in the UI and then click a button in the UI to import it or refresh it and it'll show up in the UI and work as if you created it in the UI. So they're fully interoperable, 100%.
So if I take this whole folder that we just created and did here, like what Charles mentioned, and go to our the UI folder where I have this UI data. So if you have seen how the file architecture on the UI side looks like is like this. So if I go and paste the folder here, this is in the simulations folder within Sandbox. And now if I open my UI, we have an
refresh, top right. Refresh database.
so it identified that there's a new folder we pasted. You see the folder is here, and you can look up. It identifies that it was already run. The value was set to 1.1. You can also visualize. So it's very simple, fully interoperable.
And so that was all in response to a question on, are settings and input files universal?
Yes.
And so yes, for any simulation, the format is identical. And so always, if you have a question, you can open up a past simulation as well, just to see the structure that underlies those files. And then there's a follow-up question, which was, are we able to use restart files when submitting simulations using the CLI?
That is a little bit work in progress. So there are a couple of features that I'm working on. So probably in about a week or 10 days, we will include that. Yeah.
So stay tuned.
Yeah. If no other questions, I will stop sharing so that we can get back. Thank you guys. Thanks a lot.